So this is Paul, Jorge, and I's final presentation on wireless solid set canopy delivery system for tree cooling. So let's go ahead and get started. So our problem statement here, global climate change has increased global temperatures since the 19th century, accelerating sharply during the last 35 years as CO2 gas released into the atmosphere has increased. This increase in global temperatures has affected agricultural crops around the world. California temperatures have increased by 1.7 degrees Celsius in the last century, and CalAdapt projects a 2.7 degrees Celsius to 4.3 degrees Celsius increase in annual temperatures for California. Kern County has begun experiencing higher than average winter temperatures and is predicted to undergo an average increase of 1.8 degrees Celsius to 4.5 degrees Celsius annually. So the United States produces 47% of the world's pistachios. California produced 98.5% of the nation's pistachios, valued at 1.9 million in 2017. And Kern County in southern San Joaquin Valley produced 44% of California's pistachios in 2017. Due to the increase in popularity due to the increase in popularity for pistachios last year, the pistachio crop in Kern County alone generated $1.06 billion. In 2015, an increase in winter temperatures was believed to be the primary factor, causing a 47% drop in the pistachio crop production for that year. So pistachio trees require 850 hours below 45 degrees between November 1st and March 30th. If the winter chill is insufficient, it can severely reduce the crop yields and the crop quality that year. When chilling requirements are not completely fulfilled, trees display irregular and temporarily spread out flowering, leading to inhomogeneous crop development, production of blank or empty nuts, and can substantially reduce the value of the crop. I recently had the opportunity to see this firsthand. We went out to Coalinga to tour one of the owner's larger orchards a couple weeks ago, and that is where the pictures you can see here were taken. This was taken after the harvest was finished for the year. As you can see, the nuts, there are still nuts on the tree. These are due to bloom synchronism being off, causing irregular pollination. All of these nuts will go on the ground this year, so they'll be wasted. But a large number of them are empty shells, like the one that you can see pictured in Paul's hand there. So our existing research attempts to make a more resilient strand of pistachio trees requiring fewer chill hours has been started. However, it may still be a while before they're successful, and even then it will likely be another 7 years before those trees begin to produce. There is also ongoing research with a dormancy breaking chemical, but again, there's still a lot more work to be done in that respect. Tests of winter applied kaolin clay or calcium carbonate based chemicals intended to either reflect solar radiation or diffuse it are also underway. However, the data thus far suggests that spraying these materials to mitigate the negative effects of warm winter temperatures does not assure you of a normal crop, but it might prevent no crop. In July of the year 2000, a preliminary evaporative cooling trial was set up to test effects on cherry trees. There was a significant difference in the flowering times of these trees. The sprinkled trees flowered approximately 2 weeks earlier than the unsprinkled trees. So that's a good thing there. And our objective, until now, this method of increasing winter chill hours has not been attempted on pistachio trees in particular. Seeing the positive results rendered on cherry trees, we anticipated this to be an effective method in battling the effects of warmer winter weather on the pistachio crops. Our objective was to design a system that will allow us to have control of the growing environment's temperature, This can be achieved by incorporating an above tree canopy misting system. By utilizing various technologies, we can attempt to decrease the ambient temperature of the grove, artificially producing the necessary winter chill requirement. So after this, we should have a brief virtual tour.
Pistachio orchard located in the west region of Bakersfield, California. This was an ideal location. The 2 acres of trees were divided into 2 sections. The section shown here in this aerial photograph is where we set up our equipment to run our tests. Perpendicular to this section, not shown in the aerial photograph, there's another acre of trees with a similar layout, providing us with the perfect control zone. There's enough separation between the 2 sections that the system should have little, if any, effect on the control zone, yet still close enough together that we can disregard any other outside variables for being responsible for any differences in the tree's performance. We divided the orchard up into 8 separate zones. Each zone consists of 4 pistachio trees, each with a nozzle suspended above it approximately 8 meters. One has 4 identical nozzles, and every zone features a different type of nozzle. We're also testing to determine what type of misting is the most effective for evaporative cooling. So the nozzles range from a fine mist to heavy droplets. Here we have a total of 32 pistachio trees under evaluation. Temperature monitoring is managed in each zone by a mesh network of individual wireless sensors and transmitters. Each device is equipped with a small solar panel with an MPPT charging controller and LiPo battery. The information is collected and then broadcast to the central control utilizing the Zigbee network using XP modules. Temperature data is collected using a TMP36 sensor positioned near the end of the branches where the new budding will occur. This information, once collected, is then transmitted to a smart control system where it's evaluated and then posted to a cloud-based database. The temperature data is found to be above a set threshold. The smart control system will activate the solid-state canopy delivery system and begin a period of misting. This period will last for 30 minutes, and then the system will shut down for 30 minutes, allowing the thermal equilibrium to stabilize before being evaluated again. The system will repeat this process indefinitely until the initial condition of ambient temperature is satisfied. Theoretically, misting with a solid-state canopy delivery system should modify the microclimate and increase chilling through evaporative cooling, providing an environmental-friendly solution to enhance winter chill hours.
Right, so this is our Google Cloud and Firebase. So for this presentation, I am going to show you a couple graphs right here. There's 5 of them. Data, where we have time, where we're tracking days, experiments, and as you can see, the lines which are showing you different zones are giving you different feedback, different results. Basically, we're trying to get as much, accurate results as we possibly can in this experiment. The more accurate we can be, the better. So for this, we have a system that utilizes IoT with its Internet of Things. And this is a new technology. With our cloud-based storage and control, it is built on the Google Cloud platform and uses Firebase for our online storage database. This allows us to log historical temperature data and system events in an off-site database, which is really good, really good for us. We can keep track of it without being on the specific database or that specific site. The Google Cloud platform provides the framework to build web-based applications to view current and historical data. We will monitor the system health and even control the system remotely, which is, really cool. This is the good thing about the internet and Google and all these Firebases. They're basically giving us the options to do everything we could do in person over the internet, which is really good for anyone. We just have busy lives. We got to keep track of it somehow. All right, guys. So our current prototype, and these are our results with A and B right here. As you can see, one of them has a system on and off once. The other one has a on, system off, system on, system off, and as you can see, the variables and time and just in general, the temperatures changed drastically. So for the misting zones, it is a blue solid line, and for the control zone, it is that red squiggly line on both of them. We are measuring temperatures still in Celsius. So for this, the system so essentially when the red line, it represents the ambient temperature with Celsius of the control zone, absolutely no misting. The red line means none. Control, which makes us have that variable there. The blue one or the black one represents The blue one represents the temperature in zone 1. The vertical black line presents the start valve, which valve 1 is on, and stop means valve 1 is off. Okay, guys. For the next results, we did another experiment 3. And from experiment 3, as you can see, data changes. Our temperature decreases in each zone. The vertical black line indicates when the valve opened, and when the orange vertical line indicates when the valve is closed. And take a look, very similar to last. You can see right here, but definitely more zones, so definitely more variables. Control is consistent though. Variables are definitely changed. All right, for a prototype, we are gonna go and work on improvements. This is a crucial for any sort of experiment. We'll be adding the addition of solar radiation sensor, either on the weather box station or each tree sensor box. We'll also have the addition of soil moisture sensors to each sensor box as a fail-safe, just in case the system fails, to prevent accidental damage to the trees in case of that system failure, so it won't cause overmisting. For our future expansion, Albert Einstein, with his ideas, just like us getting ideas, we are all learning and we're all trying to improve. So, and especially for the future, we gotta have it ready. We will definitely explore the effects of full temperature control over the entire dormant season, creating optimal temperature reduction to place these trees into dormancy. We will have controlled temperature reduction throughout dormancy and optimal temperature increases to bring them out. We will explore system scalability to deploy into larger scale growth, full scale growth. So essentially we're trying to expand. We don't want to be, it's a good here, but we want to expand. We want to make this the future. This is what everyone should use. Okay, so in next steps, we will measure and evaluate the following with more ideas. We will review the results, determine the duration of misting, whether it be hours or treatment at different temperatures, review the results, and study intervals between applications to conserve water within hours and days, and determine when evaporating cooling ceases at different temperatures. We will review the results to determine the most effective droplet size. The droplet size to have the most maximum evaporative cooling duration. These study logs are going to be used to evaluate the amount of water applied, whether it be volume, centimeters per application, and we will follow up not just with grove owners to discuss flower quality evaluation with regards to bloom synchrony, pollen, and ovular viabilities, and also post-harvest fruit quality data. Tree yields nuts rating by the facility factory. Okay, guys, and thank you guys for allowing us to share research with you. This couldn't have been possible without the funding from the California Department of Agriculture's Block Specialty Program, CDFA, and everything, all these contents are solely our responsibility. The authors, and not necessarily represent the official views of the CDFA.